So as I recommend, so just start off by launching the notebooks and then get pull the sort of instructions from the GitHub page. And as always, you can always you'll find the link to it in the course environment tab. So there it is. It takes a second to launch it, but once it's done, so then we can just clone the repository. Yep. So this week on the lectures you discuss sort of the future of cartography and a bit of how AI might play a role in that and these sort of future prospects type of thing. One part of that is sort of interactive web mapping, which isn't really sort of the future, it's already here. There are ways to do it, but one way to sort of do this is use these libraries in the Python exercise. They explored a bit, and then in the QGIS one, we have a really nice exercise. Two, in fact, one small one about exporting these web maps, and then a more extensive one about doing various sort of spatio-temporal exploration within QGIS. And then playing around with animation, so how to create an animated map of a phenomena. So we'll sort of add the temporal dimension into this week's mix. And as always, there's a few prerequisites. First of all, a plugin called DataPlotly is used. So it's a plugin for it's a plugin for creating these various sort of plots within QGIS, scatter plots, bar plots, whatever, all the basic stuff, and it uses the Python library Plotly underneath. So it's a nice sort of extension to QGIS. So you can do this sort of traditional non-geographic plots within QGIS and use it to sort of understand the data that you're working with. And we'll also add a few plots into our maps. Yeah, and the data that we're working with is this remote sensing data by NASA, and you can always download it from here, or you find it in the data folder. And then a secondary data set that we'll use to filter the data, so about Korean land cover. So we need to find the industrial areas of Finland. But this FIRMS data is basically tries to capture wildfires in the environment, and it's been limited to Finland. And it's point data with some timestamps attached to it, and this data that we're working with covers about 10 years, so you can just download it wherever you want. I guess downloads is fine. I have it in my folder. So, and then there's another sort of QGIS file, so you will need this data if you want to run this project, sort of do the data pre-processing stuff and stylization. And you will also find the style files of the layers in this folder. So kicking off, always good to just, well, we need to import the data, and to do that, since the data we're working with is CSV data, so delimited text, so just start working through wherever you save this. Files for me, I'll have them in here. So navigate to file data for map. And it should automatically identify that, okay, now we're working with CSV data and its point coordinates with longitude and latitude information. If not, then insert them yourself. and then there's a date date field in there. Just add, and then we have the point data in there. Might as well add the second one. So that is Korean industrial areas. Yep, and right away you of course notice that the coordinate reference system is all wrong for our purposes because it's data for Finland. So the first thing is to set the project coordinate reference system to the 3067, and then reproject the data itself because we will need it in a proper coordinate system. So reproject this file data from map to EPSG 3067. Just so. Then another thing, like to explore the data a bit and check out how the attribute table looks. But one thing you might notice that we don't have like a unique identifier for each data point. Actually, there's a processing tool for that. So in the processing toolbox, there's an auto incremental field. Sounds fancy, but basically just adds a running number, a new field as a running number. So now we imported the data, we reprojected it, and then this is sort of the starting off with sort of so that we have all that we need in the later sections. So importing it as a CSV file, then reprojecting the layer and making sure that your project is in 3067, and then adding this auto incremental field in the layer. So now you'd have this this layer got incremented, and this should now have everything that we need for the later explorations. So we worked with various like spatial variants, and of course mapping is about showing something spatially, but a lot of information is also temporal. It has a when variable attached to it, so we'll use that to advantage. And actually QGIS has nice temporal controllers, so you can explore data not just spatially but temporally, and that can be and should be activated from the layer properties. And then there's a separate tab for temporal stuff, and it needs to be activated, this dynamic temporal control. And there's various sort of options that how you could express the time. So it expects the layer to have some sort of information attached to it. For example, it could have a start time and an end time, or duration, or something like this. But we only have a single field for date and time. We have the sort of observation date, so we'll use that one, and that's easy Q date. And then the event duration, and this is something that's sort of needs to be figured out case by case. So how long does this event last? So these are wildfires. For visualization purposes, we'll set the event to last 1 week. Was it now? No, 1 month. Yeah, so that it's visible in the map for 1 month, which of course it exaggerates the length of the actual event, but we do that for a good reason. So we've activated so the temporal controller for this field, and now you should see this this clock symbol next to the layer, which marks that it's a temporal layer now. And then we can start by activating the sort of temporal controller panel, we can start playing around with that. And if you don't see it right away, so then it's hidden on the view and panels. So there's a temporal controller. So just click and it should activate. And in here, there's animated temporal navigation. So now we'll start sort of, we need to fine tune this a bit. So this basically decides what's drawn on the map view for that layer, so that it will only draw things that are currently in view. So that's essence in the sort of current frame. And first of all, we need to set animation range, and we can do that simply by clicking here. So now we have the range from our layer, so from 2012 to 2022. Then we need to set an animation or temporal step. So how much do we advance the time with sort of each notch. And now it's only 1 hour, and that's way too little for 10 years. So actually we can set that we advance by one week. So each step advances this by 1 week. And now we can see that these fire events are starting to appear on the map. And then actually it's probably a good idea to add a background map. You should have quick map services installed, so you can add just a standard OpenStreetMap background map, so you can see a bit of where these fires are happening. And if you want to make this advance a bit faster, so then you can actually, it's hidden annoyingly behind this symbol here, so you can advance this animation by more frames per second. So now if we set it to 5, so then we're sort of moving faster, moving forward a lot faster. So we set the temporal range, then we set the step, so how many days or which time period we'll advance in with each step. And then we set how many frames are changed per each second, so that basically makes the map move forward faster. Yep, and now you can see the current frame here. So for example, at the moment we're in 2015, and then these are the fires that happened at or near that date in 2015. And this can be a really nice way to sort of explore your data temporally. And we'll use this later on to create an animation. And if you play around with a bit and zoom around, you'll see some fires that occur, like, yeah, that makes sense. There's some fires in sort of green areas. But there's actually something weird with this data currently as well. So you might wonder why there's observations, constant observations in this area near Oulu. And actually, if you zoom in and you have the background map in the, you notice there's a bunch of heat observations here, and those all fall within the Raha Steelworks. So it's actually coming heat signature from a factory and not from a natural wildfire. And the same is true for there's a cement factory here, for example. So we have some noisy data. And if you want to sort of map this phenomena, map wildfires as they occur in Finland, so then we need to work through this oddity a bit, so filter the data. And for that, I prepared the Korean industrial areas layer. So the objective is to sort of filter the data that's not wildfire observations, but not filter any observations that would be wildfires, basically. So not to capture any true positives. So we'll use this layer, and we'll actually capture a bit outside of it. So we'll use this processing tool, select within distance. So select all of these observations that fall within these industrial areas, and then within 1000 meters of them. And we'll create a new selection. So now we have the observations that we wouldn't want to keep. And then we need to invert the selection. So we want to keep the ones that are more than 1 kilometer away from these industrial areas. So we can just, I guess it's Control and R, or there's this symbol for inverting the selection. Like so. And then there's, we can extract the selected features. Yeah, extract selected features in layer incremented. And with that, if we started off with about 12,000 observations, now we should be down to 2,500. So actually, let's say 70-75% of our data was pure noise. So we had observations from industrial areas and sort of heat output from those factories that wasn't at all what we wanted to present. So now we should have a better data set with this simple filtering step. And now we need to copy this temporal controllers thing to the selected features. So you can do that. Copy and paste. Yeah, so we'll continue working on this temporal stuff later on. Let's take a bit of a detour to this interactive plotting and exploration within QGIS. So we know how the data is distributed, and we know a bit about the temporal aspect of it as well, but we could also sort of, we don't know, for example, which are the peak months of our observation, stuff like that, like basic exploration stuff that's easy to do with Python and these plotting libraries, but not as simple to do within QGIS. So first, make sure that you installed Dataplotly. It should be just in the basic plugin repository, and then you can launch the doc from here. So there should be a small symbol in the toolbar, or then I think you can find it also from view and panels. Yeah, view and panels. You can find it also from there. So that's a new doc, and here you have power to sort of create various types of plots. And we'll start off with a simple bar plot. So let's say we now want to know which is the peak months of wildfire observations in Finland. Sadly, we don't have that data in sort of ready-made in the fields, but we can derive from it. We can derive it from the data that we have. So we'll say that and actually set the correct layer. So we'll say that we want to plot the x-axis on. We have the month on x-axis, so we can derive it from the data information. There's a function for it. So basically, this month function extracts only the month part from the date. And then for the y-axis, we'll count how many unique observations are in each month. So this is the field that we count in, and this is a group by expression that group all these 12 different months together. So copy and paste that to the y field. And then one more thing, there's another layout option. So you can, in this layout options thing, you could play around with font sizes and and titles and stuff like that. But from here we set the bar mode to overlay. And with that, if we create the plot, yeah, and actually probably also let's not show the legend. So yeah, so now we have a plot, and I think that's pretty neat that we can also do that in QGIS. It might not be the best way to do this, but it's functional. And as expected, these wildfires are peaking during the drier and warmer months in Finland. It doesn't make much sense that there would be many wildfires in January or February, which they aren't. Actually, the peak month by far is May, which is interesting. So this, I think, Data Plotly in general is a pretty powerful plugin if you're gonna do this sort of basic data exploration. And if you have like data, if you have interesting data in the fields themselves, so you could do like scatter plots or violin plots or whatever. This is just showing sort of the distribution of the data in one way. And later on we'll add these plots to the actual layout itself. Yep. So let's start working towards that. Let's make a simple hex bin map of how the data is distributed. And this is something that we've done before, so it should be fairly straightforward. We'll create a grid. Using the tool make grid. Oh, no, not made. Create grid. I guess that's more legit. An hexagon grid, an extent comes from the layer selected features, so we don't need to have a larger extent than the data itself. And let's make it so that these grid cells are 25 by 25 kilometers. Run it. Yes, that looks about correct. Then we count how many points, how many observations fall within these polygons. So polygon is a grid, points are selected features, and rest are fine. Like so. And then finally we drop the cells that have no observations then at all. So we can do it with extract by attribute. So we define that we'll only want to keep the grid cells that have number of points that are above 0, and that should give us a nice cell like that. And now you could do basic symbolization for it. Doesn't need to be anything too fancy. We can just define it as a graduated layer with number of points, and then classify it with natural breaks, like so. Let's say 4 classes. Choose some sort of functional symbology, maybe like something like that. So that's enough. Because the point is now, if we went to where to create a print layout, we can set the page to portrait mode. Or actually no, let's keep it in landscape mode because we'll need that extra space. So I'm going to demonstrate to you how we can add these plots as an extra information for sort of interpreting the phenomena. So if we now have the map here, and we'll have it, and quickly add a bit of styling, nothing too fancy. Yep. So we have the map there. And that gives us a bit of information of how the sort of phenomena is distributed. So where those wildfires are happening, we see them that they're happening mostly in the sort of southern, maybe a bit in the western part of Finland. I guess the clearest sort of clearest phenomena is that we have more fires in the south than in the north, which makes sense because there's more farmlands, there's more dense forest and more human activity in the south. So that's useful information, but we can actually tell a bit more if we add another plot here. So data plotly also adds this small tool in the toolbar in the layout item. And unfortunately, we have to sort of recreate this plot, so we can't import it, as far as I know, from where. Yeah, I don't think we can recreate it from the sort of outer view. So I'll just quickly work through it. So we have a bar plot with these counts of how many fires happen in each month. Yeah, and then we can just make it smaller. And of course, if you add a plot like this, so then you would have to fine tune it a lot, add a proper title for it, and make these fonts a lot bigger. They're for some reason really small. So fine tune it a bit. I won't do that right now, but you just know that you can do it pretty easily. And you could then, like the final output map could be something like this. So then there's an example map here with the sort of hex bin of observations. And then these two plots that sort of give a bit of an extra information of what's happening. So we get wildfires by month, so we see the sort of temporal distribution, not taking into account when in which year this happened, but just the month. And then there's this another one that bins the wildfire observation together by latitude. So we have that information in the fields as well, so we can use it to advantage to show that yes, there's a clear sort of south-north gradient happening here. So of course, maps are pretty powerful by themselves, so do keep in mind that is it wise to sort of overload the reader with information? Maybe not. Maybe this can be mostly for your aid to sort of understand the data and understand which phenomena are interesting to show, interesting to demonstrate within it. But you can just also sort of add these plots quite easily to your map and just show and tell a bit more, something that's not possible to do with the map, not as easily as not as easily anyway. So use these wisely, but do use them if the sort of if there's a need for it. So we did a bit of an interactive data exploration stuff. So, but now we can return to the sort of temporal side of things, to which we sort of explored a bit already. Now a layer is temporal. We can keep working on it to sort of create a nice animated map that shows when and where these fires occurred. So you can maybe remove or clean up these grids a bit. And we can continue working on this selected features, which should be the latest one. That has been filtered, and also make sure that it's temporal. And yeah, I mean, this could be a map, I guess, of just showing where these fires occur. So they just pop up in the map view, and then they pop off once the 1 month has passed. But actually, we can do better than that. So we can add a bit of styling to these points. And to do that, let's start working through the symbology. So first the size, instead of just popping in and out and just staying like this one size, we have the sort of benefit of this animation feature. So we can actually define that this size changes over time. And here's a really neat way to do it. So in the symbology of the select features, we define a data-defined override. And instead of writing out this expression, we'll actually use this assistant feature. And this is, we could do this same thing with expressions, but this is actually a more humane way to do this. So we'll have these fields where we can insert various values or various sort of expressions or whatever. So for the source, so again, we don't have a field ready. We'll actually derive it what we want from the data itself. And this is a bit complex, but basically we are saying that this map start time is the current frame that's currently drawn. So for example, at this moment it would be the 22nd of September in 2017. And this acquisition date is the date when the fire itself occurred. And this is subtracting the current date from the observation date. And basically that means that we can define that values from 0 to 30. So 30 days, 1 month from the observation date, we'll draw something on the map. Actually, if we now activate the app again, you can see that that's happening. So we define that as we get further away from the observation date up until 30 days, so then keep making this symbol bigger. And now the size is going from 1 millimeter to 10 millimeters. And we can fine tune it a bit, let's say 1 millimeter to 8 millimeters, for example. So now it's like linearly getting bigger. We can actually even make it a bit nicer by applying this transform curve. So instead of moving to one direction, like you can see the linear expansion here, we can pretty much freely define how big it is at each moment in time. So think of this x-axis as time and y-axis as size. And now we can make it so that if, for example, have it pop up quite small, and then it stays biggish for a while, and then it disappears. So you can see this. You can see how it looks like live. You can fine tune it a bit and see how it starts to change. So that's pretty neat. Yeah, it could be something like that. I have an example curve here. You can apply that or fine tune it as you like. So basically now we're saying that start off quite small, then get to the full size, stay there for a while, and then fizzle out over time. And then I guess we could set some sort of red color for the files. I think it makes sense. A transparent stroke. And we can apply the same idea to, for example, transparency or opacity. So instead of staying this solid blob for the whole observation time, we can apply this same sort of transformation curve and same sort of temporal change to the opacity. And we can also apply this transformation curve to opacity. So, for example, I did it so that it starts off quite visible, and then it sort of fades out. So that creates a nice effect where these old observations are starting to sort of disappear from the map, disappear from memory, and disappear from our observations. So again, there's an example curve here. You can use that by copying this wildfire temporal point style. Yeah, and then you should see something like this in your map. So you can see it on the map view, but it's not. We somehow have to move from this to the actual animation. So I think this is starting to look quite nice, and we can walk. This would be like a good enough map for just showing the change and where files are happening over time. So we have to, let's move on to exporting the information. So sadly, QGIS cannot export animation, so the video files. It can only export the single frames of animation, which is too bad, but actually it's quite easy then to use another software to animate the actual video. So for us, it's enough to just, yeah, we can work with that, but exporting the animation is a bit of a hassle. So instead of using the usual layout window, so like creating a new layout here and so forth, actually the animation is exported directly from this map view here. So we're not actually using the layout for this, which is a bit counterintuitive. It's not something that we're used to. At least I see that it's wise to sort of think of this view as what's gonna then be rendered on the output. So if we limit like this, and then there's an export animation button here, so we could right away export our frames, but actually it's a bit useless, for example, for a map viewer if they don't know what they're actually seeing, and especially for a temporal map like this, it's important to know the current date that's being shown. So we'll need to add some sort of dynamic text on the map view, and since we're not working with layouts, we can't use the usual routes. We have to do this bit of a hack, so we can add these what are called decorations. For example, a title label we can add here. So we use this title label to advantage. So you could have something like wildfires in Finland if you enable it first. So then it appears here, and then it's actually like stuck to the map view, and then it's also rendered with the frames that we output. And by the way, I want to show you something really cool. So these QGIS can actually simulate various sort of color blindness from the map view. So I've seen from your exercise reports that some of you use outside tools for simulating, sort of testing out whether your color scheme is suitable for various sort of color blindness, and that's great. I just found out that you can do this within QGIS, so just activate one of these, and then it actually renders the current map view as if you had one of these color vision deficiencies. I assume that works like that. So quite nice. And you can also, if you want to just see how your map would work in a grayscale, so you can also use it for that purpose. Okay, that was a bit of a detour. So we have this wildfires in Finland, but it's this quite ugly block of text on the top of the map view. So we can continue. Thankfully, we can move it around a bit and have something, have it look a bit different. So first of all, let's increase the font size by quite a lot. Let's say I can do it here. So let's say 25, and we can remove this ugly background bar color from there. Let's say it's in the top right corner. So if you now apply these changes, so you should see them. Yeah, now it's stuck in there. And we can move it a bit down still. Again, this is a bit of a hack. So let's say horizontal and vertical margin from the edge is 25. Yeah, we can do something like that, and we can actually, yeah. So now we have a title, but it doesn't still tell us anything about when this stuff is happening. But actually, we can add this sort of dynamic component in the title. So again, we're using expressions, and we're extracting the current date, the date that's in the temporal controller at any point with this map start time variable, and then using this format date function to format it as month and year. So to make it sort of clear what's happening, so we can do it like that. Actually, we can't. We have to do it from here. And then it inserts it correctly. Yeah. So wildfires in May 2014, for example, and if we move around this temporal controller, so then you can see that this month and year information is also changing. So that's very useful to us when we export the frames. So then this information will be encoded in there. And then all that's left is to sort of style this map a bit. For example, this OpenStreetMap background map is a bit ugly. It's also a lot noisier than we would really need for this sort of map. So what I did, for example, in the example map is to add the simple world background map. And it's a mess at the beginning because there's because some of these sort of polygons are rendered incorrectly because this the CRS isn't meant for a global map. So then it creates a lot of problems for us. We can actually just filter out this useless information from this. So if you don't know how to do that, there's this SQL-like filter function for each layer, and I use this a lot, and it's a really handy tool. So we can define by which features we are filtering by. So if we say that we filter by name, and let's say we wanna only have Finland in there, so we can do it like this. So name equals Finland, and then we only have Finland in our map. So let's have one for Finland, and then another one where we'll have these bordering regions. And here we say that name should be Russia, Sweden, Norway, or Estonia. Something like that. And of course then you should style it a bit. Have these background regions be lower in the hierarchy, so have Finland stand out a bit more. No, I did it wrong way. Have Finland stand out a bit more. That looks ugly now, but there's a better example here in the output. Yeah, something like that. You don't need that much information, I don't think. You don't need the whole background map for something like this, and it can just like distract from the actual topic of the map, which is now where white files occur. But of course you could enhance this map by adding, for example, locations of major cities or something that would help the reader to orient themselves. But I guess that's good enough for now. Then we can move on to exporting this animation. So, as mentioned, this exports a bunch of individual frames of animation from QGIS. And for that, I recommend that you have a separate layer ready. Not layer, have a separate folder for this. So I have this animations folder, create a similar one, and then name it like wildfire frames. And then make sure that this why is it now not changing? Yeah, and then have it output as something, for example, wildfire map. And then these hashtag symbols will be replaced with a running number. So instead of hashtags, it will be like wildfire map 000, wildfire map 001, 2, 3, 4, and so forth. Well, it's explained there. And then we can make sure that your output is JPEGs instead of PNGs, because that makes the individual frames a lot smaller. So this will take a bunch of space on your hard drive, but JPEGs will be a lot smaller. So the extent, we could use this map canvas extent. It might be wise. If you are unhappy with the map canvas, you can also just, for example, draw the extent which is exported. For example, like this. And now it's exporting only that area. And then make sure that these active decorations are drawn for the title label, for example, is included. And then you can limit the temporal range or yeah, for example, set 1 year export or have the whole time period. And then the step. So that should be okay. So 1 week of advancement. And then you would just press save, which I won't do now because it takes a while and I have already exported these maps previously. And I guess one more thing that I forgot to mention about this animation. So this 1 week is fine, but if you want to do it, make it more smooth, so you can always, for example, decrease this time step. So you can see that this animation where the symbol becomes larger and then smaller is a lot smoother. And you could make this frame rate faster to also make the animation advance a bit faster. So these are trade-offs. If you want to make a smoother animation, so then you can export more frames, but then that's more data on your hard drive, and it takes a bit longer to render the animation. But with something like that, you would have these frames. And then finally the output would be something like this. And by the way, these example maps are rendered as GIFs, so they're quite ugly. There's a lot of banding and the colors are a bit off. So that's because I wanted to make sure that they're rendered in the notebook itself. But you should use something like MP4s or whatever if you want to export the map. So with that folder of frames, your next step would be to pass it on to another program where you can actually render it as a video. And I have linked to a few of those here. So there's this command line tools that's quite complex to use. There's this free and open source video editor called Shotcut, which I used. So that's quite simple. I could just start off a Shotcut. And then I have the animation files here, or frames. I could draw one of these frames here. And then in properties, set that as image sequence. And now it's rendered as a video. And you can actually, one important thing to note of this animation is that you have to set the frame rate yourself. So basically the higher the frame rate, the faster it advances, or in this case it's actually the opposite. So if I now set to 4 frames per picture, so and then I export it in here, so yeah, it's advancing by 25 frames per second. And each frame stays, each picture stays for 5 frames, for example, now. So then each picture lasts 1/5 of a second. But that's quite complex, but you could play around with this and then have some sort of nice output at suitable speed, so that it's enough to sort of interpret what's happening, but not slow enough to become a slog. And then there's also like online tools. I think, for example, this EasyGIF is probably the simplest way to do it. So you can just have these files, you can zip them up and then paste them, copy that zip file here, and then you should have your animated map almost right away. Yeah, we're almost done with this exercise. If you want to replicate it, so you can use this wildfire preprocessing model in the QGIS files. It wants to do, for example, this temporal exporting, so it will only pre-process the data, create the grid map, and create the points to the and apply these style files to them. So you will still need to do some clicking if you want to create an animation like this, but it will help you a bit. If you want to do a stretch call, so I added an idea here where you can use this spatial temporal clustering to, instead of showing off these individual point observations, which are usually actually showing one wildfire might have multiple observations on multiple days because they last a while. So you could cluster these points together with this spatial temporal DP scan algorithm within QGIS. So explore that if you want. Next, a very quick tutorial of this web mapping in QGIS. So for that, you need this QGIS to web plugin. So again, another plugin, another tutorial, and another plugin. And this plugin does exactly what it promises. So if you have a project where you have like you're visualizing data, but you want to share it online, of course the easiest way is to create a web map. And this way to create the web map, and we'll do exactly that. A very quick and dirty one here. So we'll be working with this province data and population within that province in Finland by Statistics Finland. You should have the geopackage in the data folder. So this province is population 2023. If you check it out a bit, you have links to the metadata in the instructions, but you have the basic information, name and ID codes, and then population counts and percentages, and then this population counts by different age groups and by gender. So simple stuff. You could style it a bit add a background map, for example. So we can also have these background maps in the web maps, which is quite cool. I'll just apply the style so that I prepared beforehand. So and you'll find in the QGIS files, and in there's this provinces population style. So it should add a graduated style for this age group of people over the age of 65, and the percentage of which share of population is over that threshold in each province. And then there's a labeling, just labels for the areas as well. So how would one actually create this web map? Well, the basic idea is to create as finished a map as possible within QGIS. So make it like everything ready, all the styles, all the classifications, all the field information, all the labels and stuff like that. So have those ready. And once you're done, you can launch QGIS to web. Let's create web map. And then there's this lot of stuff happening here. So actually it now seems, yeah, I have this stuff, like it remembers what I did previously. So you might see something a bit different, but you could update this preview, and then it actually shows you how your map will look like as a web version. So it uses either open layers or leaflet, and both are libraries for creating these web maps. You don't need to worry about too much what each of these do. I think that open layers is, for example, fine. You can just keep the standard or the default settings as they are. But here you can define which layers are included in the map. Does that map have pop-ups? And if it has, so then which fields are shown in those pop-ups? So here you could define that all fields are hidden. But actually we want to have a few fields visible, so we can have the name in there. Then we have the variable that we symbolized. So the age of people over 65. So we can set that as inline label that's always visible. And actually this is quite impressive in the sense what you see here. It's impressive in the sense that it's actually porting over this QGIS styles to do the open layers symbology. So it's trying to recreate the best of the possibilities what's happening over in QGIS to this web symbology, and it works out quite nicely. All the style is in there and stuff like that. But actually, this label outlooks are a bit different. So if they are if this buffer that we set up is quite thick in QGIS, it's almost invisible within these open layers. So we actually have to exaggerate it quite a lot. We now set it like this, so it looks quite goofy within QGIS. Well, then in open layers, now it looks quite okay. So now it actually looks fine. So there might be a bit of fine tuning, but otherwise it's okay. Yeah, then you could, like, if you need some detailed information, best way to go is the like documentation here. But we could play around a bit and sort of a layers list expanded. Let's now remember there's a lot of stuff here. expanded, yeah. And then we define which are included as layers, so we'll use that. We have that one. So that means that we'll have a legend for our map visible for the users. Then we can have this layer search. So if people want to see what's the situation in their province, so we can actually add a search bar in the match project CRS. So then it's rendered in 3067. Show pop-ups and hover, sure. And then we can define that people can like zoom out like this, which doesn't make sense. Or they can zoom out in like this, which again doesn't make sense for our map. So we can set maximum and minimum zoom levels. Max zoom level 10 and min zoom level 6. So now we're quite restricted, actually, once we update the preview. Yeah, so now you can see the legend. Of course, you could tune it a bit, change these names and have it look a bit nicer, but you get the idea. Yeah, and with that, once you're done with your web map, you can just press export. And then it creates this these folders, these files in a folder that's predefined. I think now it's set. Now it went to temporal. It went to what is it now? Yeah, it didn't went to a permanent location, but anyway, now you can see how your web map will look like. And let's see. So yeah, it exported into this location, and if we check it out in there, so there's this set of folders that it created. I guess this is the latest one, and you could copy these. You should copy these sort of the whole folder somewhere if you want to share your file. So there's good instructions on how to publish these interactive maps. I think they're made from the perspective of the HTML, these index HTML maps, which are created by the Python tools, but actually there's also a similar one here. So this index HTML is the one that you need to run. You click it here, so then it just opens up in your web browser this map. But if you copy this whole folder over, for example, if you follow these instructions on how to do it in GitHub Pages, so then you can have it stored online and served online. So this is an example that I have in my personal GitHub Pages, and yeah, if you want to create a web map, then it's of course somewhat limited. We don't have, for example, the temporal controllers here, which would be nice. But still, if you want to share something, then this is a pretty nice way to do it from QGIS. And with that, I think we're about to wrap this tutorial and these tutorial sections of the course up. So you've done nice work with the exercises and keep on doing those. You still have 1 week to go. Yeah, and I thank you for the course.